Hey everybody, my name is Lester Martin. I'm here from Starburst. I'm a developer advocate, and we have an action-packed 20-ish minute demo for you. And I'm trying to do a whole data engineering pipeline from source to data product. Do all that in 20 minutes flat. So what I can't do, and I don't have time to do, is show you a bunch of slides. So I'm going to give you one picture, and then we're going to jump in. It'll be a straight hands-on activity. I will say that we do have a chat session going there. You're welcome to ask me some questions. I'll probably wait to the end to look at them. Where I'm on the road, I only have one screen here, so I don't really see them right now. But if you have something urgent, I do have a colleague in the background kind of watching the chat for us. Maybe just mention it again or uppercase it or say, hey, can we answer this one now? So if something mission critical comes up, definitely do that, and we'll get my attention. Otherwise, when I finish up, I'll go back and read all the questions and make sure you're answered, and I can stay a little longer than the 20 minutes or so. All right, so what are we going to do? We're going to do a solution here that's based on a general use case that says, hey, we have some Pokemon Go game data that exists, and if you're not familiar with Pokemon Go, it's a game, an interactive game, a virtual reality game or enhanced reality game where these little monsters show up and you go chase them with your phone. But what we're tracking is the data of those monster surfing, those pocket monsters, those Pokemon. So we're going to see that, as you see on the left here, that information is already being supplied and put on an Amazon S3 object store bucket. And what are we going to do with that? We're going to use our tooling called the schema discovery, and we're going to create the bronze tier, the raw tier, the land tier, whatever term you like to represent that information in that medallion architecture. And then we're going to say, great, we have that. What's next? Well, we're going to build a silver layer. Silver layers are usually where we adjust, naming conventions, data types. We do augmentations, enrichments. But what are we building? We're building a silver layer. The silver layer is data that's reportable, solid, correct, all that good stuff. The problem with silver layers is often the questions you ask and that basic format don't really mesh together, and sometimes performance can be degraded. So we create one more layer, gold layer, and that's really where we think about our query-focused data sets that make those queries that you want to ask happen a lot faster. So it could be, or look simpler. It could be a view that hides the complexity of a multi-table join. Could be a materialized view that does some roll-up aggregates just to make it faster, those kinds of things. And then lastly, we'll talk about using what we call data products. How can we then further market those curated data sets and get them out there? I'm going to jump on in. Last thing to say is we're going to show that this engine is a single point of access engine that lets us see data from lots of places. We talked about the data lake, this Pokemon Go data, but I do have another table, a Pokedex for those that are Pokemon fans. And I'm storing that in Snowflake, and I'm going to leverage that. I'm going to do some federated joining across Snowflake and S3. Why? To build a better silver table, to help build some gold tables and that kind of good stuff. So let's jump on in. And I'm going to run a quick query, just make sure this thing stays alive. I'm using Starburst Galaxy. There should be some links available to you. If you don't see them anywhere, we're going to definitely send you an email at the end that says, click here, join up. And the trick about Starburst Galaxy, you get about $500 of free credits. But the account is free forever. And the clusters that you run within that, there is a type of cluster called a free cluster. I'm going to use that today exclusively. The only problem with free cluster is if you sit idle for about 5 minutes, it'll quiesce and shut down, and you'll incur a few seconds startup time. So I'm just kind of nudging it to keep alive. All right, so let's jump on in. First thing I'm going to do is say, I'm going to go find that data I talked about. So I already created a catalog here. We'll call it AWS Pokemon. It's configured to know all about the particular bucket that I want to store some data. And I'm going to go to what we call the catalog view of that, catalog connector, whatever term you like. And that was AWS Pokemon. And in this world, I can see a list of schemas and that kind of stuff, but I'm going to go to a tool we call Schema Discovery. And I'm going to say, hey, I want to go look at this particular location, this bucket, this folder. And what I want you to do when you're there is take a hard look at the data that you find there. So I'm going to run this schema discovery. A few seconds later, it's going to come back and say, hey, Lester, what I found is the fact I can probably build a table called Pokemon. Why? Because there's some data that was there. You pointed me to it. I told it what schema to land it in, and the catalog is where I started. So I'm gonna say, yeah, that's what I want you to do. So I'm gonna say create the tables. It could find a lot more if I targeted another location that had more details. This just had one folder full of information. So it's gonna go off and actually take that discovery information and build primarily some data definition language, create tables. In fact, it's gonna build this very specific create table Pokemon. It's in this catalog schema table. Here's the data sets, the attributes, columns, column types, kind of stuff. And it's actually creating a Hive external table, if you're familiar with that concept. If you're not, it's a Hive table, and hopefully that term means a little something to a lot of us. The cool news is I'm finished with that, and I can go back in my query editor, query editor, and I should have a little query toward the top here already kind of pre-populated to help me out here. Let's see if I can find that thing. I could actually go over here too and say, hey, show me that catalog. And there's the schema, discover schema that I dropped it in. Kind of a silly name. You might want to pick a better name, but that's the default name. And there's a table called Pokemon. That was the one that got created. I could go from here and say, hey, I want to tell me what that table looked like from a description, from a definition. Show create table should give me the exact same DDL I generated from that tool. It sure did. Pokemon, these fields, so on and so forth. And I should be able to, query that data set. So there we go. This is what I'm looking for. Select schema, Pokemon, discovered schema. There we go. Select all from Pokemon. See if that'll find it. That should just show us that spawn data I mentioned. Hey, this Weedle at this lat long location at this certain time showed up. Here's when it disappeared, that kind of stuff. So it's presence. This is sensor data. This is transactional data, whatever's appropriate in your world. And in fact, we're done. We've already created our raw table as is, nothing changed, that kind of stuff. Now, the reality is we probably want to march forward and create, a silver zone. So I'm going to go ahead and create a schema. I'll call it AWS Pokemon LM for Lester Martin demo. And if all went well, over here, there should be a new schema. Well, I guess the metadata takes a second or two to show up. Let's see if it'll show up this time. There is LM demo. It's empty. So what I want to do is go ahead and I'm going to give myself a little bit more room. I'm going to build this table right here. Let me run it and we'll talk about it. What is this table? Well, this is my silver, my structure table that I want to represent that data. Now, I went a little elaborate on the name Pokemon spawns. It's not just Pokemon spawn data. And because I'm going to use one schema for my silver and my gold tables and objects, I just went ahead and kind of postfixed it with the name silver. Probably not what you do in a production environment, but just to kind of keep it short and sweet. So for the most part, I just changed the names are slightly different. I actually think I got rid of a column or two. And I'm going to use a type of table definition or table type called Apache Iceberg. It's going to use a file format type called Apache Parquet. There's nothing in that table today. If I ran a query on it, it would come up empty. So what I'm going to do is say, hey, look, I did a lot of work as a data engineer and discovering and found out about the quality of the data and everything. And ultimately what I realized is, hey, this query right here from line 48 downward is enough to solve the raw to silver or the bronze to silver transformation, cleanups, enrichments. It isn't very much, right? I just rounded down the lat long values. I did some casting, something that was, I believe, a varchar, where I said, no, it's really a number. I played with the timestamps and kind of got rid of milliseconds of duration, just brought it down to seconds. So I'm tracking how long was this encounter? How long was this Pokemon around when it spawned up and disappeared and that kind of stuff. And then I also, for giggles, I went ahead and actually just trimmed down a smaller set of data, actually like 95,000 rows. I've targeted a very specific lat long area. Now, I would say normally this part you may or may not do. I'm doing it because my business user said, all I care about is the San Francisco area. And I said, let me put everything in there. And they argued with me and they said, no, I only want that environment. So I said, fine. And I said, I'm okay because next month, when they care about Portland and New York City, I still have all the data in the raw. I can bring that data in. when they need it. It's really, just making that kind of point about the value of the raw data. What did I do? I ran that query and then I inserted into that Pokemon silver table. If I run a quick query on that, what we should see, magically, we went from a bronze to silver. We're doing good. We're about 10 minutes in. We're doing pretty good. And there we go. Weedle, this spawn number 13 is a Weedle this that long. And then we use that. When did it show up? When it disappeared? Just basically said, hey, it was around, this number of seconds, and so on and so on and so forth. So some of those are kind of big. Some of those are kind of small. And what I also said is, hey, there's actually, if you remember this picture right here, so we built the bronze with our tool that interpreted what it found, built the table for us. That was fast. That was neat. Could have done that from scratch, but why not use the tool? We did a lot of work as a data engineer and set up pretty easy set of cleansing, enrichment, that kind of stuff. So we created a silver layer. And then this engine allows us to connect to a whole bunch of different data sources. And I have some lookup information over in Snowflake. In fact, you can see that right in this cluster. We got Pokemon lookup. Now that's pre-configured. I set that up earlier. Didn't have time to run through it with you. But there's a table called Pokemon lookup, or for Pokemon fans, it's a Pokedex. There we go. There's the table, Pokedex. And if you want to see the contents of the Pokedex, I'll just run this query. So we're just doing a single query off to Snowflake now, saying, hey, what do you see there? And we should see things like, hey, there's a Bulbasaur. If you're very familiar, it's what type of Pokemon, what's the secondary type, how many HP, so on and so forth. This is good stuff, valuable data. One would argue, is that bronze, is that silver, is that gold? I would call it silver because I know enough about my system to say, hey, that is rigorous, solid, reportable, correct, all that kind of good stuff data. So I actually have another logical thing in my silver layer, and I'm making that point because your silver layer could be a lot of things. It didn't have to only be in the data lake. We could copy that over, but we don't need it all the time. We look up things, maybe we'll aggregate it based on that kind of stuff. So I want to show that point. But more than likely, what we want to do with that data is this. We might want to say, hey, could I meld that S3 silver table with the Snowflake table? Can I do a join? Absolutely. So there we go. Pull data from two different systems into our underlying Trino query engine and did a federated query or distributed join across multiple different data sources. And if you look, really what we added, just added the types, type definitions, catch rate, so on and so forth. Now, I might go ahead and say, you know what? That would be a good gold table. So I'm going to go ahead and say, hey, my gold, I'll start working on that gold tier. I'll say create table, run the same query I just showed you, and just populate it. So I chose on this one to be not a view, not a materialized view, but create an actual net new table. So I owned that. So I'm gonna have to own keeping that current, update it regularly. I can do that via just simple scheduling, and I can do that with a DBT model that orchestrates things, all kinds of interesting things. But I do have, and let's see if we can see some of those tables now, hopefully here when this reloads. There we go. There's my silver tier and gold tier tables. Let's see if I can stretch this out a teeny bit. Pokemon final spawns, Pokemon spawn silver. This is a gold guy. This is my silver. I use that silver name in there. What else can I do there? Well, I could say, not so sure. Oh, I'm just going to say, can I look at it here? Let me just toggle to not the discovery schema, but the LM demo schema, and then just run. I showed you the join results, but here is the table that we just built. Yeah, this looks like a table. Now people can get all that benefit from running a simple query that's a little more optimized. The join didn't have to happen. And this is what I meant, at least in my solution, in my architecture, I decided to do that up front. If I was doing a join every single time and there was some performance issue over time, I might choose to actually replicate that data from Snowflake. But the solution I took, it works perfectly fine. All right, so now we want to transition into our gold tier. So people had some specific questions. One of those was this. Let me kick it off and I'll tell you what we're trying to run here, if my node isn't lying to me. All right, so I'm gonna run a quick query. This query, as my nodes kind of say, is hey, I'm gonna look at the Pokemon type, grass type, electric type, that kind of stuff. And I'm ordered a Pokemon that I have to spawn data by the number of times they spawn. So who's kind of the most popular? And I use the windowing function and that kind of stuff. And if you look really, really close, I kind of said, hey, for bug types. The most popular are Weedles, Caterpies. I don't remember this one and this one. Metapods. Metapod's a bug type. So there's a rank column here. So 1, 2, 3, 4, 5. So I'm just ranking all of them just to kind of get my appetite wet. And then I realized, you know what, this is kind of what I'm looking for. I'm going to build a view that is that same query with a little bit more. I went ahead and said, you know what I really want is the most popular type by a most popular Pokemon by type. So I took that same query, but jazzed it up a teeny bit and really trimmed it down to make sure, hey, I only want the ranks that are number 1 itself. So if I did that, if I ran a query on that new view, that new view will should be over here on the side. Yep, there it is, popular types in San Francisco view. Then there we go. I see that the bug type, the most popular is the Weedle. I don't see it's ranked number 1 because I only wanted ranked number 1. The Bulbasaur is the most popular grass. And then I'm trying to look for a Pokemon that I know about, Pidgely and that kind of good stuff is a normal type, so on and so forth. I think Pikachu is electric, right? So I don't know if we saw electric in there. So the most popular electric was a Voltorb, and my son will probably slap me. I probably pronounced it wrong. I had about 803 SKUs spawns in there. So really what I did pretty quick there, it's about 16 after. I'm trying to do it in about 20 minutes. I'm already here. I built 1 silver table. I used our tool in the created. I'm sorry, 1 raw table or 1 bronze table, and could have done it from scratch, but I used our tool to kind of figure it out for us. I did a lot of work and realized, my silver tier isn't much, pretty close already. I'm pretty good quality, that kind of stuff, but did some standardizations and trimming, that kind of stuff. I went ahead and realized that, hey, I already have some other silver tables that logically already exist. And then I built 2 gold layer objects. Those were this final spawns. It's the culmination of two different data sets from 2 different places. And then I went ahead and built 1 quick view that says, hey, tell me the most popular types in San Francisco. Now, what I could do here is, and I don't have time to do it, I absolutely could go and create all kinds of governance and access policies using classical things like role-based access controls that we all know and love, just like databases have. I could also build a subset of attribute-based access controls, or ABAC. The type of that we could do is a tag-based attribute. So we can go in there and tag a table or schema or a column with some particular thing like PII or cool stuff. And then I could build rules against who could or couldn't see cool stuff, or could or couldn't see PII. I just don't have time to do that. But what I wanted to show is the fact that the reality is, this system allows people to have, because of single point access, see lots of data sets. And maybe what we're going to do is we're going to take some time and curate and explain and populate some information. So we have this concept we call a data product. And normally what you would do, slightly different in Starburst Enterprise than Starburst Galaxy. In this case, I'm going to go and look at this cluster. This catalog. The one I've been working on, AWS Pokemon. I'm going to look at that schema, which is LM demo, Lester Martin demo. And I could go in here and add all kinds of cool descriptions, fill in some metadata, so on and so forth. I could add some tags here, another. I could add a contact. I think I'm already at contact. Yep. Thanks. See, cool. Update some high-level stuff. I could drill into each one of the tables and the views, explain what that is, write some details up here, write details at the column level, descriptions, add more tags. They're inheriting another tag. But ultimately, after I decorated it pretty heavily there, I'm going to go back to my schema and say, this is the schema that I want to offer up as a data product. So I'm just going to promote it to a data product. I'm going to bring forward that information. And here's my chance to name it something, provide, some more description, use markup language, etc., add links. When people want to look at this, start to run this and query this, is there a default cluster in case they don't pick one, that kind of stuff. So I'm going to do a promotion, and then I can spend time in this product. So this is a decorated view of a schema with objects in there. Now, I don't have time being 219 to fully decorate it, so I went ahead and created another one. I created a data product I called Air and Space, and just to kind of show you the art of the possible. So if someone found the Air and Space data product, and they could have found it from a lot of ways. They could have just, were out here typing, they could have typed NASA or something like that, And based on what you're kind of looking for, I might have said, okay, that's cool, but I'm looking for data products specifically. See if that didn't find it. Interesting. Maybe I didn't put in the name of the data product. Ultimately, you can use all this stuff and find things, that kind of global search. But again, I'm just going to go navigate to it. Get back to it, data products, and say airspace. Here is that data product. Here's what it's all about at a high level. It's about NASA and FAA data sets. Here's some high level metadata, more details. So think of this as like a wiki page about that schema, and including who, when created it, how long it runs, all kinds of other metrics. And most importantly, of course, not just the high level, but what are the data sets that are in there? So really the objects in that schema, because the actual querying of that is going to use the same schema and objects and access and everything. This is a architecture of basically defining as a data producer things. And this is going to carry forward all that information we just talked about, column descriptions, explain what this is, etc. The tags would be there, separates it by views. You could, many of these you can simply just show me a quick preview. I was trying to look for one that's something more than that one. There we go. Show me what that thing looks like. So this is something you would offer up for folks to find. People via this GUI tool, people or applications via REST API. And to be honest, an AI agent, now you have an opportunity to provide a lot more information. In fact, our AI agent that's in our private preview right now is geared around these data products. And if you provide a lot more information, that's going to make that textual conversation really ultimately get to a quick answer. One of my favorite things, though, is this, uses examples. Those objects may or may not be that awesome. They're pretty awesome, but maybe you still need a whole bunch of other queries. So here's an example of taking that astronaut data. Here's a query. You look at that and you say, what is this? It's about this. What if you wanted to find out how many times John Glenn went to space, but what you really care about is on his various flights, where was the percentage breakdown? Where do you spend the most time on flight 1, flight 2, etc.? So there we go. I wrote a description. You can kick it off. You can edit it and detail it. You can hit, hey, I want to go run this thing, open up a query editor. And when you actually query data, not preview it, not look at the descriptions, you're just back in the regular tooling. So in this GUI or in your BI tool or in your data application, we don't fundamentally change how data is working. We just give you this additional descriptive environment. In fact, if you look here, our indicators tell us that. It says, hey, this is really a schema called aviation, but it also has a data product wrapped around it called air and space. And there we go. There's that question right there. I'll run it in the background, and my cluster quiesced in the meantime, so it'll come back up. And I'm about 2 minutes longer than my 20-minute target, but the good news is that let me get there. Now, I'm going to take a quick peek at the chat. I'm going to slide this over so you guys don't see a mirror reflection and see if there are any questions in there. And it looks like Anne is the biggest question out there. So this demo is trying to show the acceleration Starburst provides to bring Medallion architecture in play more quickly. Is there an AI component to this? So the AI component, I would say there are some AI components, but there isn't a universal solve everything. So some of the things that I didn't show here would be, one would argue that schema discovery isn't necessarily AI, it's more procedural logic that's kind of looking and finding things. But we do offer a concept called auto tagging, where we use AI that says, hey, go look at the data sets that are out there and maybe offer up some suggestions. And the preeminent one that's going to come up is things like personally identifiable information, and that raises it up. But no, we don't have an AI aspect that would just simply say, okay, cool, I know what your business rules are. Thanks. And for that, I know what your specific business rules and your user scenarios. They could exist. You could build an AI agent that does that, but we haven't focused on that. Our big other efforts in AI that I didn't demo here today. I have a webinar. If you look in our events page, I don't think it's showing there, but it's coming up in about 3 or 4 weeks. We have a concept called AI functions. We can create embeddings. We can store those embeddings, those vector embeddings, what we call lakeside, on as another column on an Apache Iceberg table, and we can not just create and store that. We can do all that from an SQL. So I have if you want to hang around or if you want to ping me separately, I've got some blog posts and videos showing some of those scenarios that we'll cover in a little more detail in a webinar coming up. So I hope that helps some. Are there any other questions for anyone that's still around? Hopefully that was a fast-paced but somewhat interesting use of your time. And I think the session is trying to auto shut down on this. I think we'll still be here just in case you're around. But I'll wait about another 10, 15 seconds. And if I don't see any other chat messages, I will simply say thank you for your time today. I appreciate it very much. And look for the email that follows up with this. That'll give you some more details, some more links, and absolutely point you to how you get started with Starburst Galaxy. All right, that's it for me. Y'all have a great day and a great night or whatever it is, and we'll catch you on the flip side. Thanks.